Today we are going to be talking about resistors and potentiometers, and resistance itself. So everything has a resistance. So anything from, say, just a standard ordinary wire right here, and this has a resistance. It's very small, so it means it's just a small piece of wire. The resistors also have resistance, as you would expect. They are good because they can in a very small space they have a high resistance in comparison to other things. Also, air is a resistor. That's why you don't see lightning bolts everywhere. Only lightning bolts with enough energy to overcome this resistance can actually strike the ground. Sorry, no, thunder. Yeah. Yeah, so resistance, everything contains resistance. So the equation for resistance, the equation used most often is V equals IR. So, which means is voltage equals current times resistance, which means that the voltage is the energy that each electron has, is equal to the current, which is the flow of electricity, times electrons, times the resistance. So the resistance is how easy or difficult it is for electrons to flow through a wire. So I have here a bunch of resistors that I got in a kit with Arduino. Yeah, so you can get, with resistors you can get loads of different types of resistors. There are color bands on them, and I'll get to that later on in the video and what that means. But so each of the color bands is each color means a different number and so on. But you can get bunches of resistors for varying different ohms. Ohms is the unit for resistance, and you can get really big ohm resistors. Like here I think I have a 5 mega ohm resistor, which is huge. Yep. And anything from that to something small as 100 ohm resistor. Actually, I think this is a 100 kilo ohm resistor, but I have much smaller ohm resistors. With a multimeter, you can use a multimeter and set it to its resistance value, and you can use that to check the resistance of a resistor or a wire or anything really. Okay, so yeah, resistors, the color bands. What do the color bands mean? So each color is a different. It has a different number, and then on the end there is either a colour of gold, silver, or brown, I believe. Sticker that I have. If I zoom in, each of the colours have a different value. So, for example, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, grey is 8, white is 9. And but that's for the first, second, and third band. You also have the multiplier, which is the last band. You can sometimes have, and that just means that it's multiplied by. So for black, it's 0. Sorry, I didn't include black in the first one. Black was 0 ohms, and that's just used for say if you wanted to have brown, black would be 100. Here 100, and then you have the multiplier, so maybe it's brown, black, yellow. It'd be 100 times 10 kilo ohms, which is a mega ohm. And then you have the tolerance at the end, which is the leeway of how accurate the resistors are. So you can have high tolerance of 1%. Sorry, a low tolerance of 1%, then you don't have much difference in the resistors value. Well, you could have gold and silver, which is more common, and gold is 5% and silver is 10%. Yeah, so uses of resistors. So, okay, so say I had a 5-volt power supply, and then I have an LED which requires 3 volts. This is called the forward voltage, and this is called the source voltage. Yep. Source voltage and the forward. Forward voltage. And I wanted to find a resistor that I could connect the source to the LED with. And a way to do that is you've also got to know the source amperage. So the source amperage in this case is 1 amp. And yeah, and with these values you can then find the resistance using the formula source volts minus forward voltage divided by current in amps. Let's write that out. Source voltage minus forward voltage over current. So an example with this would be 5 minus 3 over 1. And that is 2 over 1, which equals 2. So you want a resistor 2 ohms. And that's the kind of resistance that you would require in a circuit like this. Okay, for this I'm going to take a resistance of a value of say 47 kilo ohms. And I want to find the bands on this. So I look at the this sheet and I say, right, I want 47. So yellow is 4. So I take yellow. I want yellow. 7, which is purple. So I want yellow, purple, and then kilo ohms. 1 kilo ohm multiplier is orange, so I want yellow, violet, orange. And I go and I search my resistor, my box of resistors, and I see if I can find resistor with yellow, violet, and orange colours. And then I found it, and here is a resistor with yellow, violet, and orange. And then on the end it's the tolerance value, which is gold, which is plus or minus 5%. But that it doesn't matter. We've got the 47 kilo ohm resistor right there. But now, say I want to identify a resistor. So say I have a resistor that it's all by itself in the box and I have no idea what value it is. I look at the colours, and on the colours it shows me it's brown, black and red. So I come and I take a look at this sheet and I have a look for brown, which is 1, black, which is 2, and red, no, not third band, it's the last band, and red is in the 100 kilo ohms. So what was that? 10 times 100, 10 times 100 equals 1000. So that is a 1 kilo ohm resistor. Okay, so here, probably can't see it very well, but we have blue resistors, and they have 5 bands, not 4 or less. So you don't need to panic. You use the exact same sheet, and apart from you look at it as with 5 bands. It starts off with brown, which is a 1, and then it goes to black and black, which is 0 and 0, and then the fourth one is a multiplier, which is also brown. So that was 100 times 10, which is 1000, and that's a 1 kilo ohm resistor. You can get different color values for the same resistance, which is interesting. Potentiometers. They come in all shapes and sizes. I have here many different potentiometers, all essentially do the same thing. Potentiometers are resistors, apart from you can vary them. So they're variable resistors, but they're not exactly like variable resistors. They have a slight difference. You'd expect a variable resistor to have 2 prongs. However, every single potentiometer you come across has 3 prongs. Why? With potentiometers, you have 3 prongs because each potentiometer gives 2 values of resistance at any given time. You have the middle pin, which is generally the one that's in the middle, and that is what you connect. You have to connect to in every single potentiometer you connect to, and the dial on the top. That is that's what you spin, and then there's a needle on a dial, and that connects to a loop that goes around there. And here is the resistant material. Here there'd probably be coils of wire which increase resistance, kind of like a variable resistor. And when you spin the dial, the dial is either on one side, so the dial could be here, and you have a resistance of a very small resistance here in between these 2 pins, and a very high resistance in between these 2 pins because you've got to go all the way around. Or if you spin the dial and it goes all the way around here, you have the exact opposite. You have a really low resistance in between these pins and a really high resistance in between these pins. If you put it in the middle, you can have it half-half. You can change it just by changing the angle. Why do we need that? Simply because it gives more functionality. Say I only wanted a variable resistor, so I only wanted 2 pins, and I don't really need the 3rd pin. But we can use these for both. So I can buy a bunch of, instead of buying some potentiometers, some variable resistors, I can buy a bunch of potentiometers and use some of them as variable resistors and some as potentiometers. Yeah, a good use for potentiometers is controlling a servo motor. So what I'd do is I'd hook this up to an Arduino, say for example, and then I'd hook the Arduino up to a servo motor, and as I turn the dial, then the resistance changes in between all 3 pins, and that tells the Arduino, when it notices that there's a difference in resistance, it will tell the Arduino to send information to a servo motor. Depending on the code that you put in the Arduino, it will send information to the servo motor, and you can change the angle of the servo motor. So yeah, there are loads of different kinds of potentiometers. You probably all have seen a potentiometer before, despite never actually probably seeing something like this, or this, or something like this. You've all probably seen a potentiometer in use. Those dimmer switches that you have in your lights, they use a potentiometer to vary the amount of electricity that goes through and to the lights, so therefore dimming the bulb, like a variable resistor. They come in all shapes and sizes. So this is a kilo ohm resistor, a potentiometer. Sorry, 100 kilo ohm potentiometer. Right here. That's 100 kilo ohm, and that's barely the size of my fingertip. And so is this. This is a 100 kilo ohm potentiometer, and it's much bigger. If you want a side-to-side comparison, here we go. That's both of them. And they're both exactly the same values. You see, it doesn't really matter. Just like resistors, it doesn't really matter the size. So I could have a really high value resistor, and it'd be really small, and a really low value resistor, and that'd be really big, or vice versa. it depends on where it was produced, when it was produced, and things like that. And as technology advances, things get smaller, so resistors are getting smaller. I have hundreds of resistors in my phone, and the resistance of them could be bigger or bigger or smaller than any of these resistors that I have in my tray of resistors. Anyway guys, thanks for watching. Like, comment and subscribe.